Potential energy of a spring. When a spring is stretched or compressed without acceleration, some work is done by an external force. This work gets stored in the spring in the form of potential energy. When the spring is stretched or compressed, a restoring force is set up in the spring due to its elasticity, which is directly proportional to the change in its length. Restoring force is given by F is directly proportional to X. F is equal to minus Kx, where K is equal to force constant of the spring and negative sign shows that it always acts in the direction opposite to the change. Then, external force required at this instant is given by F is equal to Kx, work done by the external force in further changing its length by dx is dw is equal to dot product of F vector and dx vector, or dw is equal to kx dx. Now, the total amount of work done by the external force in changing its length by L is given by W is equal to integration of dw. By calculating it, we get W is equal to 1 upon 2kl square. Then, potential energy of a spring on changing its length by L is potential energy is equal to W. Potential energy is equal to half kl square.
For more such videos on all subjects, practice questions and a lot more, download iPrep and learn unlimited.